So it could be anything that's going in a circle. So we've been using this example of a bug on the tip of a fan blade going around in a circle. So what quantities have we been focusing on in this situation? So talk to the person next to you. What quantities, and 1 and 2 word answers will not cut it. All right, to explain these quantities takes a phrase, a long phrase. What quantities are we interested in? What are we focusing on? Go. There are 3. There are 3 quantities we're focusing on. Go. 3. Okay. What is one of these? What is one of these quantities that we're focusing on? Got one?
The angle measure in radians starting at the 3 o'clock position.
Okay, pretty good. Just one more detail. So the angle measure, or the measure of the angle. Good. Measure the angle swept counterclockwise from the 3 o'clock position. That's where it all begins. And that's a change, right? So that's a changing quantity. That's why I'm showing it and going, right? So as that angle is sweeping counterclockwise from the 3 o'clock position, we're focusing on some other quantities. So this is the first one. Measure the angle swept counterclockwise from the 3 o'clock position. That's number 1. What's another? So given this angle, what is another quantity that we're focused on? Given this angle. Go ahead.
Horizontal distance to the right.
Horizontal distance, right.
The horizontal diameter.
Wow. A vertical diameter. And what unit are we using? What unit are we using to measure that horizontal distance? Radians is angle measure. So it's not radians. Fraction of radius length. So radius length or fraction of radius length. Okay, so it's given an angle. So as this angle is continually changing, that horizontal distance is continually changing. It's going out. What's the maximum value of that quantity? What's the maximum value of this quantity, the horizontal distance, right of the vertical diameter as a fraction of the radius length? 1, right? So when it gets to the right side of the circle, that horizontal distance achieves its max value of 1. And what's the minimum value? At the left side of the circle, -1. Okay, and then next quantity. So the third quantity that we're interested in is Lola. Good, excellent. The vertical distance above the horizontal diameter as a fraction of the radius length. What's its maximum value? Where? For what angle? For what angle swept counterclockwise do we get the maximum vertical distance of 1? Pi over 2. And the minimum is? 1.5 pi, right? Or 3 pi over 2. It's going to be -1, that vertical distance, okay? And For what angle or angles is this vertical distance above the horizontal diameter 0? For what angle or angles is this vertical distance 0? So it's actually, so in one rotation, it's actually 3 times, right?
Yeah.
0, pi, and 2 pi, the vertical distance is 0. Okay, and so we said that this is called, the second quantity is called what?
Oh.
Horizontal distance right of vertical diameter as fraction of the radius length is the output of what function? Cosine, for an input of that first quantity, theta. So this is what we call theta. That's cosine theta, and this one is sine theta. So with the cosine and the sine, what are we doing? We are marking the position of the changing position of something going around in a circle given an angle, right? So given a changing angle, we're tracking the changing coordinates or the changing position using cosine and sine. Cosine is telling us how far left or right. Sine is telling us how far up and down. And together we pinpoint the position of, in this case, the bug for any given angle swept. Okay? So let's summarize here. This. Ready? Okay, so fill in the blanks. Don't miss any. So next week's quiz is part of the quiz is this, and you got to have all the details, right? So again, these are long phrases that are needed to describe these quantities, not 1 and 2 word answers. So go practice. So practice without looking at what we just did. Okay. So if you wrote down what we just did, don't look at that. Practice again here. So what's the input and output of sine? Input and output of cosine, and then what coordinate are those? Oops. Okay, Javon, tell me. What's the input into sine? Okay, so what about Odie? What's the input into sine?
Would it be the measure of the angle
Okay.
at 3 o'clock, kind of going counterclockwise?
Okay, measure the angle swept counterclockwise from the 3 o'clock position. Measure of the angle swept counterclockwise from the 3 o'clock position. Output. What's the output of sine? Tell me your name again. What is it? Elijah.
It's the height above or below the horizontal
Measured in?
fraction of
Measured in the fraction of the radius length, right? Fraction of the radius. Vertical distance. And so what, I don't know, so you saw this a little bit in the web work. What unit circle coordinate is that? So if this is, if the horizontal diameter and the vertical diameter are axes of graphing plane, right? So what coordinate are we talking about with sine? It's the y coordinate, right? Vertical distance is your y coordinate, how high up or down you are. Okay, cosine theta, input. Bam.
Oh, the measure of angle swept counterclockwise from 3 o'clock.
Exact same input. They have the exact same inputs, that same angle for both of them, exactly, right. And what's the output?
Horizontal distance. Yeah, we're cosine. Horizontal distance right of the vertical diameter and fraction of radius.
That's it. Fraction of the radius length, right? Radius length, yeah. Coordinate. So we're talking about a horizontal distance in your math career for the last 15 years of your life. That was the x coordinate, right? Horizontal distance is the x coordinate. How far left or right? X coordinate. So I want you to estimate. No calculators. No calculators for this scenario that's up here in the circle in the upper left. Estimate theta, sine theta, and cosine theta for this scenario. So you're going to estimate. No calculator. Theta in radians. So theta can be any angle measure unit. It could be degrees, doesn't matter. Do it in radians. So estimate theta in radians. Okay, compare what you did with the person next to you. Talk about it. Compare. See if you agree. Okay, let's see what you guys came up with. So, Gary, what about theta? Did you come up with something for theta?
It looks like it's
0.8 for theta?
Oh, no, I mean, 2.
Around 2. What do you guys think? Maybe, yeah, 2 or a little bit more. If you said 2, 2.1, something like that. Yeah, 2.2. That's 2 is fine. Okay, sine theta. Keep going, Gary.
0.8.
He wants 0.8. Yep. Good estimate. 0.8, about 4/5 of the way up. Okay, somebody new. Let's see. Levi, cosine theta. Negative 0.6. What do you guys think? Good, they nailed it. Okay, so you should have something close to those. Something close to those. If so, then you're getting what's going on. So if we wanted to write the coordinates of this point then, what are the coordinates of that point? So if we want to write it as, because after all, we were after the location of the bug for any angle, right? So we went on the location. So that's going to require 2 coordinates. So what would I write? What do I write first? Negative 0.6 and 0.8. So as coordinates, so it's the cosine is the x-coordinate and the sine is the y-coordinate. Okay, now suppose this is a moon revolving around its planet. Okay, so planet and moon. And the radius is 88 billion miles. So again, sorry. So I want to know how many billion miles, right here, the moon is right here, how many billion miles above the horizontal diameter and to the right of the vertical diameter it is. No calculator. So if you need to write an expression, that's fine. So if you need to write out an expression, but so what would the coordinates be in billions of miles? So yeah, so you think about these numbers as fraction of a radius, and now our radius is 88 billion miles. So what do we want? We want 0.6 of 88 billion. So what? So let's get that. So do that. Do a negative 0.6 times 88. And as soon as you get it, tell me. Negative 53. These are estimates. So in billions of miles, so now it's negative 53, or 53 to the left, or negative 53 to the right. And what's 0.8 times 88 billion? What is it? 70? 70 billion miles up. So this is the beauty of this sine and cosine. It's universal for all circles because it's based on the fraction of the radius length. So given any radius, then you just take that fraction of your radius to get your coordinates in this, whatever unit your radius is in. So if your radius is in meters and you've got the fraction of the radius length, you're going to take that fraction of the radius in meters to get how many meters you are to the left and right. So the coordinates of the moon could be negative 0.6, 0.8, measured in fraction of radius, or negative 53 and 70, measured as billions of miles. Both of those are legitimate. Okay, and so then this then is universal for all circles, and theta. Those values are universal for all circles. Doesn't matter how small or big the circle is. These values stay the same as you make rotations around the circle. And that's why we focus on this, because if we know the radius of our circle and we have these values, then we're set. We know everything we need to know. Okay, so let's start putting some things together here. Any questions on this kind of review? Okay, so we're going to have okay, so we're going to change the scenario here a little bit. We got a remote control car going in a circle of 8.5 feet. So first we have to pick what car we want, right? Of course, got to have a good car here. So do we want the Formula One or do we want the Lamborghini? What's that? Formula One or Lamborghini? Or the monster truck?
Monster truck.
A monster truck? But what about the smart car? Monster truck. Okay. They want the monster truck. Okay, I can do it. Okay, there it is. So here we go. So the radius of rotation, can you see the circle at least barely? There is a circle there. Okay, so the radius is 8.5 feet. So I'm going to sweep out an arc of 4 feet. So the monster truck is going in a circle, and we're going to pause time. Imagine it's going around in a circle. We're going to pause time after it's swept out an arc of 4 feet. Okay, so what angle measure in radians, so no calculators. What angle measure in radians exactly has the truck swept out? What angle measure in radians has the truck swept out? Elijah knows. Wilson knows. Someone say. Hi. Say. He wants 4 divided by 8.5. What'd you say? 4 divided by 17 pi? Okay, what is radians again? So what is radians angle measure? Radian angle measure is how many radius lengths are cut off by the rays. So how can we express how many radius lengths have been cut off by the rays? 4 over 8.5. Right? So it would be the total length of the arc, and you're asking how many 8.5s fit into that total length of arc. Okay, so that is we're going to leave it like that, 4 over 8.5. Okay, so what is the vertical distance above the horizontal diameter of the truck in radius lengths? How would you express the vertical distance above the horizontal diameter of the truck right now in radius lengths? Who knows what's going on? Yeah.
Inverse sine times 4 over 8.5.
No. So you kind of got the right idea. You just got it switched around. So we've got the angle, and we want the vertical distance. What tool or what thing gives us vertical distance if we know the angle? Sine. So the vertical distance would be sine of? What's my horizontal distance to the right of the vertical diameter in fraction of a radius? Cosine. But what I really want to know is how many feet up. How many feet up is the truck, and how many feet over is the truck? So times what by 8.5? So he wants to take both these now and times them by 8.5. And that will give me how many feet over and how many feet up I am. He agrees. So what is this? This is the fraction of the radius length, right? And this is the fraction of the radius length. So it's a number. So let's estimate. So what do you estimate cosine of 4 over 8.5 to be right now? What do you estimate cosine and sine of 4 over 8.5? Talk to your neighbor. So estimate these values right now. Estimate. Okay, estimate for cosine of this angle 4 over 8.5. What would you estimate to be? George? He said a little less than half. What do you think?
Sine?
For, so what are you saying? So you're saying a little less than half. Is that cosine or sine?
That's
Sine. So he's thinking a little less than half. What do you think? Yeah, and as an estimate, so he wants to say 0.45. A little less than half. What about sine? Estimate for sine. Tristan. Oh, no, it's for cosine. I'm sorry, that was sine.
Sorry, cosine, so like 0.7, 0.8.
0.7, 0.8. Let's go with 0.8. So now, if I wanted to know how many feet over it is and how many feet up it is, I've got these fraction of the radius. What does it make sense to do? Do what? I thought they said divide. No, he said multiply. Okay, good. So this would be the ordered pair if your coordinates are fraction of a radius. But if we want feet, then the ordered pair would be 8.5 cosine of 4 over 8.5 and 8.5 sine 4 over 8.5. And then so what are we doing? With the sine and cosine, we're taking that fraction of a whole radius, 8.5. So multiplying by the fraction gives us the fraction of 8.5, or the number of feet. Okay, so now let's go in your calculator and find these two up here. Let's see how our estimates were. So cosine of the ratio 4 over 8.5 and sine of the ratio 4 over 8.5. As soon as you get it, tell me. So exactly what? This first one, cosine is? 0.89. Okay. One more decimal place. 8.91, and this one was? Okay, so we were really close with our estimate, right? He said a little less than half, and I said 0.45, and that was almost exactly right. Okay, so now get exactly how many feet it is. Well, it's going to be 8.5 times each of those, right? You're taking those fractions of 8.5 feet gives you how many feet? 7.58 feet and 3.85 feet. So now that the position of the truck, if he goes a distance of 4 feet, he's 7.58 feet from the vertical diameter and 3.85 feet up from the horizontal diameter. Doesn't make sense. Okay. Let's do, can I erase? So two ways to express those coordinates. In fraction of the radius, that's your cosine and sine, and in feet, that would be your radius times cosine and sine, will give you feet. So both of those are valid ways to express the coordinates of that. But if I came over here and I said this specifically was the point 8.50, then which of those two would be the coordinates of the truck? So if I said that was 8.50 right there, then A or B would be the actual coordinates of the truck in this system. A or B? It would have to be B. If I'm going to call that point 8.50, then I have to use this set of coordinates to B. If I called that 1, 0, I could call that 1, 0, meaning radius lengths, then those coordinates would be this, right? Then those coordinates would be that there. Okay, I'll give you one more example, and then we'll do something else. So here we go. So how many feet are we going here? 15 feet. Go. So I want you to express the coordinates, no calculator at first, no calculator. Express the coordinates as fraction of a radius and express the coordinates as in feet. So Michael, what angle has the truck rotated here? What angle has 15 over 8.5? And what's the horizontal position of the truck as a fraction of the radius length? No, as a fraction of the radius length. So I just want the fraction of the radius length that the truck is to the right of the vertical diameter. Cosine of? And so then the vertical position as a fraction of the radius length? And if we want the coordinates in feet, right, so in feet, times 8.5. So let's do estimates in feet. So estimates in feet, what do you estimate the cosine to be in feet? What do you estimate the cosine to be in feet? Not the cosine, sorry. The position of the truck to the right in feet. First of all, negative or positive? How many feet to the right? If this is 8.5, you think it's about what? 2. So maybe negative 2. Okay? And then estimate the number of feet above the horizontal diameter. What would it be? Yeah, something greater than 8, right? So maybe 8.3. Okay, check. Check your estimates. So our estimates are negative 2 and 8.3 feet. Check them out. What is it actually? As soon as you get it, tell me. In feet. So we're getting exact coordinates of the truck in feet. Based on, so we estimated negative 2.
Negative 1.64.
Good. $8.34. Okay, we done good, right? So we get it. Everyone see how to get negative 1.64 and the 8.34, which is the exact, or not exact, but a very good approximation of where the truck is using feet as the unit of measure. We good? Okay, so I got some work for you here. Can I erase? Sorry, the spacing's a little weird. I'm trying to make it big enough here. I'll try this. Okay, so a standard track is circular on the ends with a radius to the inside lane of 36.5 feet. So his starting point is 36.50. Okay, no calculator. So we're going to use expressions for your answers. Don't use a calculator. Suppose the runner has run 22 meters counterclockwise from 3 o'clock. So let's show that. Here he goes, 22 meters. Okay? Express the corresponding angle in radians. Express his vertical distance above the horizontal diameter as a fraction of the radius length and as meters. Same with the horizontal distance to the right. And then only use a calculator when you get to part D. Okay? Only when you get to part D should you use a calculator. And then you're going to compare your answers to the situation and kind of make sense of the numbers that you're getting. Okay, and I'm going to take attendance. You can work together. Okay. So, how about Kenton? How does this go? So express the corresponding angle in radians. So what angle in radians? 22 over 36.5. Right? It's going to be the number of radius lengths. How many radius lengths is that? That's what we're asking. The openness of angle measure in radians is how many radius lengths the runner has run, which would be 22 over 36.5. Okay? So the vertical distance above the horizontal diameter as a fraction of the radius length. Let's see here. Daniel.
So it's sine. Well, first the estimate was about 0.6, and then I actually found that it was 0.5669.
No, we're just expressing them exactly. No.
Oh, sorry.
Yeah.
It's a sine of 22 over 36.5.
Sine of the angle. Sine of the angle gives us the fraction, and then in meters. So that's part one. And then in meters,
Meters would be that times 36.5.
36.5. Okay. Horizontal distance right of the vertical diameter as a fraction of the radius length. Jayu.
Cosine 22 over 36.5.
And then in meters.
36.5 times cosine of 22.
Good. Okay, so now to get actually in radius lengths in meters, we need our calculator to get good approximations for those. So in radius lengths, what did we get for radius lengths? Did we get a number here? Logan, did you get that?
Yeah, the radius lengths I got, for the coordinates,
Yep.
0.82 and 0.57.
And can you kind of say why those numbers make sense? Looking at the picture, why do those numbers make sense?
Because it's 0.82 radians from the vertical axis,
Okay.
and then 0.57 radians from the horizontal axis.
So radians is for openness of angle. So that rather than radians, you mean to say radius lengths, right? Radius lengths. Yeah. So this horizontal distance about 0.82 of a full radius, right? So it's like 4/5 of a whole radius, and then he's a little bit further than halfway up this way. That's your 0.57, or a little bit more than halfway up to the top. 57% of the way up. Okay, and then in meters, who's got it in meters?
30.07.
30.07?
Yep. And 20.69.
And that would be in meters. That would be in meters. Again, 30 is like almost all the way over. So it's like 80% of 36. 20.69 is more than halfway of 36.5 meters up. Let's do a different one here. Let's do this time here. So this is 86.5 meters. So what I want you to do is a different progression here. first thing I want you to do is estimate how many meters to the right of the vertical diameter and how many meters up. So first thing is estimate for this 86.5 meters. Estimate the position in meters. No calculator, no expressions, just then that's number one. Then number two, I want you to write the coordinates in meters and find them to check your estimates. So this number two is exact expressions. Exact expressions. And then number three is check your estimates. Check number one with number two and your calculator. Okay, go, work together. So estimate the position in meters, the two coordinates in meters. Write out those coordinates exactly as expressions, and then check your estimate using number two. It's time to go. So for Friday, it would be web work and quiz prep. Web work and quiz prep for Friday. I'll write it down as you're walking out if you want to look.
So, how many more quizzes and tests?
Well, quizzes are pretty much every week. There's one more hour exam in the final.
Okay. Yep. Thank you.
Check your grade in this class, because I
So
know
take the average of your two test scores. And then if your homework is really good, then it'll be a little higher than that. If your homework is in the middle, your average of your two test scores is